Welcome back to an intuitive introduction to probability. In this lecture I want to tell you about probability tables. Why do we use tables? So far our calculations were always on rather small examples. There was an A and a B, an intersection of A and B and so on. Often, however, we want to look at probabilities in more complex examples, and we have many different probabilities. We need to order them, we need to do some accounting and get some structure on them, and that's what probability tables are good for. Let me show you a first example of data. Here we have from a most recent year where complete data is available, the number of foreign visitors to Switzerland. Our friends in Australia and Oceania may forgive me, I left you out because your numbers weren't that large. So let's divide the world into 4 continents: Africa, the Americas, Asia and Europe. Visitors in Switzerland can stay overnight either in a hotel or in another destination. Another destination could be a caravan, could be a camping ground, it could be a youth hostel, it could be France, it could be a private house or private apartment that people rent. We see here in this particular year there were about 28.3 million visitors in total. At the bottom we see the totals of overnight stays by foreign visitors from the 4 continents. Not surprisingly, most visitors came from Europe. Switzerland is in Europe. And fewer people came from other continents where you effectively have to fly. We see that about 17 million overnight stays were in hotels, and a bit more than 11 million were in these other domiciles. Now, I think you agree with me, this table is a mess. We see these long numbers, we have numbers between 50,000 and 28 million. It's difficult to sort of look and understand this. So, this table of raw data, of counts, we typically like to translate into proportions, and then we can also use them as probabilities, using, once again, concept number 2, empirical probabilities. Here in the bottom right hand corner, with the green shade, there's always a 1, 100%. How do I get this data? If you look at the accompanying Excel spreadsheet, you will see you just divide every number by the total. 28.3 million was the total divided by itself, gives me this 1.000. We see that 60% of all overnight stays were in hotels, 40% were other. Those together, 60 plus 40, gives me the 1. At the bottom we see the percentages for the 4 continents. 1.2% for Africa, 7.5% for the Americas, 7.1% for Asia, 84.2% in Europe. You add those numbers up and guess what? We are back to 100%. In the middle we see now intersection probabilities. For example, the upper left hand corner, hotel and Africa, 0.010. So 1% of all overnight stays were by visitors from Africas in hotels. And we have 8 of these intersection probabilities. Here now a little bit of lingo from these probability tables. The numbers in the margins of the table, so at the very right column and the very bottom row, are called marginal probabilities. Here for hotel we would say P of hotel is 0.6. At the bottom, the P of Americas 7.5%, P of Asia 7.1%. So people in probability theory are not very creative or imaginative. These are indeed the margins of the table, and that's where the name came from, marginal probabilities. In the interior, in the middle, we have these intersection probabilities. As I mentioned before, probability of hotel and Africa, 1%, probability of other and Europe, 38.1%. These intersection probabilities in the interior are called joint probabilities because we're looking at joint events of hotel and Africa joining and both happening together. That's the motivation for the choice of the name. You can now scale this as far as you want. So it doesn't have to be just 2 by 4. You can have as many rows as you want. Here I use a generic M. So we have A1, A2 all the way to AM. You can have as many columns as you want. Here I use a generic K, B1, B2 to BK. Here's a requirement that these events must satisfy. A1, A2 all the way to AM need to be what's called mutually exclusive. We have heard that before in the term of disjoint. So they can't happen simultaneously, and they need to be collectively exhaustive. So here you either stay in a hotel or in other. Or you are from the Africa, the Americas, Asia or Europe. No other possibility. So that's what it means to be completely exhaustive. Mutually exclusive means either one or the other happens. So don't tell me, oh, I smoked but didn't inhale. That's nonsense. Either you smoked or you did not smoke. So there's an empty intersection and everything is covered. And then we have the joint probabilities, these intersection probabilities in the interior. The probabilities in the margins, the marginal probabilities, are then the sums across the rows or across the columns. And so here now, let me show you this. If you look at the first column, the Africa column, 1% plus 0.2% equals 1.2% in the total. If you look at the row of other, we have 0.002 plus 0.011 plus 0.007 plus 0.381. The total is 40%. So the margins is the sum of the interior. Now, probability tables are very helpful to show us the marginal or total probability of an event, probability of hotel or probability of Asia, and it's great at showing us these intersection probabilities. What these probabilities tables do not show us are conditional probabilities, but those we can now really easily calculate. Let me show you how. What is the probability that an overnight stay in other is from a person visiting from Europe? What do we do? Remember the conditional probability definition. Take the intersection probability and divide it by the probability of the event that occurred. So here, the probability of Europe given other, take the intersection probability, that's a probability in the middle, in the interior of the table, and divide it by the appropriate marginal probability. Here we learn more than 95% of all overnight stays in other, in caravans, in camping grounds, in vacation houses or apartments, in youth hostels is from European visitors. And here in the table, notice what we did. We took the 0.381, the interior probability, Europe and other, and divided by the probability of other, 0.4. So you can just take the element from the interior of the table, divide it by the marginal probability, and voila, there's your conditional probability. We can also go in the other direction, other given Europe. So what is the probability that a European visitor will stay an overnight in other? So now Europe is given. The probability of other given Europe is what we're looking for. And now we take the same intersection probability, but we're dividing by the marginal probability in the bottom row, the totals. So 0.38 divided by 0.842, and that gives me 45%. To sum up, why do we use probability tables? Things can get very quickly very ugly if we have many different events. So we need to learn to structure the representation of probabilities. Probability tables are a great way to do this. That's why we use them. In the probability tables, we see marginal probabilities and joint probabilities. And so that's why we needed to talk about these concepts. We will use these probability tables for more calculations in the next few lectures. Thanks for your attention and please come back.